Today we are going to be walking through insulin resistance, which I will explain in 3 levels. Insulin resistance occurs for a pretty long time before the onset of diagnosed disease. So I will go through how it works and how to reverse it and become more insulin sensitive. In the absence of knowledge is fear. So my goal is to bring forward as much knowledge as I can to eliminate fear and help us come into our power. First, if you like this video, give it a thumbs up and click the bell for more health and fitness educational content. My level 1 explanation of insulin resistance. Here we go. In order to walk, breathe, talk, and just live, your body needs energy from food. When we get too much energy from food, our body doesn't really know what to do with it and it gets overwhelmed. Our body goes from being a fast-moving highway for energy to a traffic jam. The feeling you get after you eat a big meal of being groggy, sleepy, and bloated is a sign that you took in more energy than your body needed and caused a traffic jam. When we ignore this feeling and we keep taking in too much energy multiple times per day for years, this is what causes insulin resistance. When we continue taking in too much energy for a while, then the body will try to tell us it needs a break through stomach aches, fatigue, skin rosacea, fat gain, and sleep insomnia, and other stuff. Now, sometimes the food we eat causes more of a traffic jam. So we are plunking cars onto our highway that break down. These foods aren't evil, we just don't want to eat them all the time. Food that sends good signals, aka more skilled drivers on our highway, are foods with very few ingredients and are usually found on the outside aisles of the grocery store. So, main takeaways from level 1, eat real food, not too much of it, and listen to your body. That's how you reverse insulin resistance. Now for the level 2 explanation. When we eat, insulin is released to get that glucose out of the blood and into the cells to be used for fuel for everything we do. Glucose is the language of energy for the body. So everything we eat, whether it's fat, protein, or carbs, needs to be in the form of glucose before it can go into the cells. Glucose needs to get into the cell because inside the cell is where the process of turning glucose into ATP happens. And ATP is the energy source our body needs to stay alive. So it's pretty important. So if the glucose journey from glucose to ATP was a movie, insulin would be like the gatekeeper character, kind of like Gandalf in Lord of the Rings, screaming, "You shall not pass," except it wants glucose to pass. So because we really like ATP, we want that journey of glucose being able to get into the cell and then turn into ATP to be really, really smooth. That process of energy production is happening all the time. In an insulin resistant body, the glucose is in the bloodstream for longer because the cells are resisting the signals from insulin to let the glucose in. This is what we see as a blood sugar spike that takes a long time to come down, which is why people with type 2 diabetes wear glucose monitors. With insulin sensitivity, we see a spike and then a swift lowering. That means insulin is able to do its job. That means that you're insulin sensitive. So what causes cells to start resisting insulin? Great question. I think we can all relate to living with or being around someone who is always asking us to do things. Eventually we get to the point where we kind of tune that person out and we don't really hear anything they say. Well, when insulin is always around, your cells start to get desensitized or tuned out. When we tune out insulin, our body releases more of it as a way of overcompensating. Also, sometimes insulin has a hard time getting to where it needs to because of issues with blood flow, but I'll get more into that in my level 3 explanation. The way to get your cells tuned back in is giving them a break from insulin for a while. By eating smaller meals and taking longer breaks between periods of eating, we are bringing relief and retuning the cells. Insulin is a hormone that tells cells to store fat, and fat storage cannot happen if there is no insulin being released. So you can retune your cells and use unwanted fat as energy when you eat more nutrient-dense foods in smaller amounts and less often. Main takeaways from level 2: eat real food, not too much of it, listen to your body. Now for my level 3 explanation. If I'm going to talk about insulin resistance in a more complex way, the gut, the liver, the pancreas, and the mitochondria are all going to be talked about because, like everything in the body, they are all very closely linked. So first off, I want to clarify that insulin changes the vibration of the cell to allow glucose inside. The most common analogy is the lock and key, where the insulin is the key that unlocks the cell to allow the glucose inside. It's a little bit different than that. It's more like a shimmy or a vibration that the cell does because cells do everything while vibrating. So just visualize the insulin binding to the cell and they do a little dance and then the glucose gets in. I just wanted to clarify that before going into my long-winded explanation of other things. I'll start with intestinal permeability. Intestinal permeability is when the tight junctions of epithelial cells in the gut become loosened, causing bigger gaps for things to pass through that shouldn't, specifically endotoxins. Endotoxins are an important character in the insulin resistance movie. They are the byproduct of our gut bacteria. These endotoxins, being in the bloodstream by getting through those junctions, cause the immune system to activate as if it is fighting off a foreign pathogen in the same way that it does for an infection. When we are funneling energy to the immune system, the body is in a state of hypersensitivity to anything that could be perceived as a threat. In other words, an increased immune response leads to fight or flight nervous system. The reason why this matters is because when your immune system is fighting off inflammation from the endotoxins that got through the gut barrier and your nervous system's in fight or flight, your cells are going to panic and shut down. This is a defense mechanism of the cell to make sure nothing gets into it that shouldn't be there. However, it means that your cells become more insulin resistant because the cell needs to be open to receiving in order to allow energy, aka glucose, in. So, in a step-by-step process, 1, intestinal permeability, 2, increased inflammation, 3, immune system response, 4, cells shut down, 5, which results in insulin resistance, 6, excess glucose gets stored as fat, for which the fancy term is de novo lipogenesis, it means fat storage, or creation of fat cells. Main takeaway: heal the lining of the gut. How do we do that? Eat foods rich in omega-3, fiber, and protein, and eat smaller meals. Now that we're on the same page about the role the gut plays in insulin resistance, I'll touch on the liver and the pancreas. The health of the liver basically determines how insulin sensitive your entire body is. The liver is what tells the pancreas to release insulin. It does this through the blood, through something called a portal system, which is a loop of blood going from the heart to the liver to the pancreas back to the heart. So we want to make sure this portal between the liver and the pancreas is clear, which means we want the bloodstream to be clear and not traffic jammed. Now, we know that when inflammation is present in the blood, there's a traffic jam. That traffic jam tells the liver to release triglycerides in the form of something called low density lipoprotein, or LDL. When you go to the doctor and they talk about good and bad cholesterol, LDL would be the bad cholesterol because too much of it will build up and cause plaques in the arteries and eventually atherosclerosis. So inflammation causes a spike in LDL from the liver. And since the liver signals to the pancreas, the liver is telling the pancreas to release tons of insulin. So we've got a massive traffic jam happening in the bloodstream, and insulin can't really get to where it needs to go very fast, which is a problem because that's how our body gets its energy. So now we've got this issue where every tissue is now insulin resistant. So at this point, we've got a bunch of stuff in the blood: endotoxins, glucose, triglycerides, immune cells, not to mention most NSAIDs like Tylenol and ibuprofen cause narrowing of the blood vessels, which makes blood pressure higher. So with the presence of insulin resistance and gut permeability, this series of events between the gut, liver, and pancreas goes something like this. 1, we eat food. 2, endotoxins get into the blood. 3, endotoxins reach the liver and the liver releases triglycerides. 4, the pancreas gets the signal to release tons of insulin. 5, the insulin moves slowly to the cells because of the traffic jam, so the glucose hangs out in the bloodstream for too long. 6, excess glucose is stored as fat, de novo lipogenesis. 7, those fat cells release another type of toxin that perpetuates inflammation. Main takeaways: make sure your liver works. The way we do that is eat foods rich in omega-3, fiber, and protein, and exercise. Now I'm going to talk about the mitochondria. So at this point, we know about the relationship between gut, liver, and pancreas. So then what happens to the glucose that actually gets into the cell? This is where the mitochondria comes in. The mitochondria is what produces ATP. ATP is the hero in the insulin resistance movie because it's what keeps our body alive. Without it, we would literally die in a few seconds. So it's pretty important. The mitochondria is an organelle in the cell where the conversion of glucose to ATP happens. Then that glucose molecule travels to the mitochondria where it will go through 3 processes. 1, glycolysis, 2, the Krebs cycle, and 3, the electron transport chain. I'm not going to go in depth in these processes because that would be a long time, but the way I remember this is by visualizing a circle. And all throughout that circle, there are different checkpoints and enzymatic reactions. Throughout this circle of reactions, with glycolysis happening outside the mitochondria and the Krebs and electron happening inside, NAD plus is reduced to NADH. ADP will turn into ATP, and there's another one that I can't quite remember right now. These compounds get put into the electron transport chain, and eventually we end up with 30 ATP. And it all started with glucose. So generally, the series of events is 1, glycolysis, 2, the Krebs cycle, 3, the electron transport chain, and then we end up with 30 ATP, which is adenosine triphosphate, which is how we stay alive as an organism. Now, your mitochondria, aside from being the miracle organelle that keeps you alive, is also very sensitive to the environment of the cell. So when the cell perceives itself to be in a threatening environment, aka inflammation, then the mitochondria will go into shutdown mode. It does this as a protective measure. Cells are either growing or burning, and a cell cannot burn and use energy and do its job when it is perceiving its environment as threatening. It also cannot contribute to its environment, so it goes rogue. This is where we start to see the accumulation of cancer cells. They're kind of like rogue cells. So that whole beautiful cycle of energy conversion gets stunted in the presence of inflammation. ATP is literally how the body functions. So when we are always inflamed, it's kind of a big deal for the mitochondria, and that's why metabolic disease is talked about so much among longevity experts, because it's kind of a big deal, and it's also very, very rampant in society right now. Main takeaway, keep your mitochondria healthy. How do we do that? By exercising at a high intensity, eating foods rich in omega-3, fiber, and protein. I also want to add that if you have a lot of muscle mass, that is the most effective way of improving your health, because it increases the number of mitochondria, and skeletal muscle is a very insulin sensitive tissue. So any excess glucose will just be shuttled right into the muscle and won't be hanging out in your bloodstream. Also, muscle releases peptides that help to lower inflammation. So to recap from the level 3 explanation, there's a lot of communication between the gut, liver, pancreas, and mitochondria itself. And I wanted to paint that picture because yes, insulin resistance is a big part of reversing metabolic syndrome, but it's just a byproduct of so many other things. Fat gain is a byproduct. Any symptom you have is downstream from other things, and it is all within your control. The body is never against you, it is always for you. You just need to learn the language of the body and interpret its messages. Thank you so much for watching. If you like this video, give it a thumbs up and let me know in the comments what resonated with you. Also, make sure you hit the bell for more health and fitness educational content. Until then, remember that you have the power to change any aspect of your life, especially your health.